Hi. I trying to find a program that will show my face while I am teaching, and that's why I am all over the place. Sorry, I am trying to pick the right microphone so my Zoom doesn't sound all garbled. Hi, it is Thursday night, and hopefully this will be the last video that I will make, and I will see you in person. And this video is to remind you of techniques of solving quadratic equations, and there are three methods that people would use to solve a quadratic equation. I'm going to show you two of them. I'm going to show you solving by factoring, which we've done a couple of times this semester so far, and also a reminder of the quadratic formula. I won't have you memorizing that formula now or throughout the year, I don't think. And I'll let you know if you need to start memorizing it. Okay, so let's get started. And hopefully when I start sharing my screen, you will be able to still see my face on playback, as it's kind of important. Here we go. To solve a quadratic equation, you can use one of these two methods or complete the square. And I'm just going to cover factoring and quadratic formula. You can only factor if you can find two numbers that multiply to make the last number, and that says multiply, and add to make the middle. Now, this is some really old notes that I pulled. That's only true if there's no number in front of the x squared. You saw this semester that is more complicated factoring, but well worth it, because solving by factoring is by far the best method if it's available to you, if it factors. So there are two numbers that multiply to make the last number, and when I use those same two numbers and add them, it makes the middle number. And so what you would do is you would create these two factors, and you want to jump to the factoring method once you have your trinomial equal to 0. So the logic behind this is if you have two numbers that multiply to make 0, one of those two numbers has to be 0. I even think I brought that up in our solving video yesterday. So the 4 and 1 numbers are going to be the numbers that you see inside the parentheses, and similar to the absolute value is that you have two options. Well, if these two are going to get multiplied together and the result is 0, then either the x plus 4 number is 0 or the x plus 1 number is 0, and really you'd have both as an option. So the graph of a quadratic equation is a parabola, and what you see is there are two different x values that would make the y value equal 0. And so you'd be basically taking a quadratic equation, letting the y equal 0, and then you're solving for the x-intercepts. Okie doke. So again, that's only if it's a possibility to be factored, and also if that right there is a 0. So I'm looking at this second question, and I see that factoring is not a possibility, because the only way to multiply and make 4 is if I did 4 times 1, or if I did 2 times 2, and adding those does not make that. So solving by factoring is actually not a possibility here. Not possible to solve by factoring. And so when I look at this last example, I don't have the trinomial on one side, and so you want to make sure that you've got a trinomial on one side and that the other side of the equation is set equal to 0 before you start thinking of two numbers that multiply to make 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. Trying to think of all the factors of 36, and then I'm going to choose the combination that when I subtract them, because the 36 is negative, I'm going to have two opposite signs when I look at these numbers. And so 9 and 4 are a good choice, or they work, right? 9 times negative 4 is negative 36, and 9 subtract 4 is 5. And so when you're solving your x's that would solve this equation would either be x equals negative 9 and also x equals 4. Again, if x were equal to negative 9, I'd get negative 9 times negative, I'd get 0. I'd get in the first parentheses, I am a little tired, to be honest. So in the first parentheses, I would get negative 9 plus 9. In the second parentheses, I would get negative 9 subtract 4. So it's that this negative 9 would make one of these two 0, not both of them. But if the first parentheses gives you a 0, it doesn't matter what is in the second parentheses, it would still make a true statement. So again, if I were to sub in x equals 4, I would get positive 13 times 0, and I'd still get a 0. So that's how you would solve by using the factoring method. So the equation that I said was not possible to solve by factoring, one go-to method that always works is using the quadratic formula. And I uploaded a couple of YouTube videos that are cute little songs for you to remember the quadratic formula. I remember there's a story that someone told me about a negative boy who wasn't sure if he wanted to go to the house party because the boy was a square. He missed out on 4 awesome chicks, and the party was over at 2 a.m. A little bit inappropriate, but it's cute in a way. And there's another story, I think, that they played poker or something, and he lost with 4 aces, but I don't know how you could lose with 4 aces. So anyway, you don't have to memorize it right away. You don't have to worry about that. What you need to learn is how to use this. And by far, the most complicated part of the quadratic formula is what's sitting right here underneath the radical. Is that you can only take the square root of certain numbers, and so you're going to have to deal with that pesky square root, which is why we spent so much time simplifying radicals. So when I look at this formula, I see that the b shows up twice. The b is whatever the coefficient of x is. And the first thing you do is you take the opposite of b. Also, you can only identify what the a, the b, and the c are is if the equation is set to equal to 0. So it's always the best thing to get a quadratic, get everything over to one side, see if you can factor it by letting it equal 0, and then if you can't, then you make another decision. So with this quadratic formula, I'm going to solve basically all 3 of these simultaneously. Hopefully that doesn't bother you. So the first thing I'm going to do is deal with this negative boy. This minus b is the opposite of the b. So if I was doing this quadratic formula, I would start with the 5, but I'd write the opposite of 5. Then I would show the plus or minus, then I'd show the radical, and then I would square the 5. So any number squared is going to give you a positive. And so I would start that way, because I'll find what the b is, I'll do the opposite, but then when I square it, I'm always going to get a positive underneath the radical. This problem number 2 has a positive 8, and so if I started using the formula, it would be negative 8 plus or minus, then I'd put a 64 right there, right? And then this last one is the b is 1 when you don't see the number there. And it's a positive 1, and so I would start with negative 1 plus or minus the square root of 1 squared, which is 1. I chuckled a little bit because I wanted to give you a negative b value, but it looks like I didn't do that. I'm sorry. So then I move on to this minus 4ac, And what I also do in my head is I multiply the A and the C together. And if I get a positive AC product, then I know I'm going to be subtracting. But then if I get a negative AC product, then I know I'm going to be adding. So I don't, yeah, it's already as complicated, of a formula as you might ever need to memorize in math. And so try to simplify things with confidence. I'm trying to show you like what I do when I do the quadratic formula. So what I do is I look at the A and the C and I multiply them together. So that's -1 times 4, right? And -1 times 4 is -4. And so that's what I am going to do basically plus 4 times 4 right there. Because minus 4AC underneath the radical, minus 4 times A times C is going to have two negatives, but minus 4AC, I look at it as -4 times A times C. And if you get a positive, this turns into adding two numbers. And if you stay negative, then you're subtracting underneath the radical. Again, I know I'm not done, but this is just how I work the quadratic formula. In this case, my A and my C multiply to also make a negative. And so once again, I would be adding, right? So -4 times A times C, that's going to give me positive 12 right there. And then lastly, sorry, I don't have, they're three separate problems, but they feel very similar because on this one, when I multiply AC, once again, I get a negative. And so underneath the radical here, I'm going to be showing a plus sign because -4 times A times C is going to result in a positive 24. Okay, and then finally, the last part of the formula is that it's all over 2A. Here in this case, A is -1. Don't forget that 2. It's just part of the formula. So 2 times -3. This is the A part of the quadratic equation, A, B, C. And then all over 2A. Okay, so let's clean this up. So this first one, I'm going to get a 16 and a 25 added together. And 25 plus 16, that's 41. And 41 is not perfect, and 41 doesn't have anything that divides into it that's perfect. So my final answer is -5 plus or minus. The square root does not come off of 41 all over -2. And I see these two negatives, but the fact that I see they're negative doesn't mean I simplify. Remember, don't just cancel these two pieces of a fraction. You want to divide it into each piece. And so technically this is showing like two separate answers, right? This is -5 plus the square root of 41 all over -2, and -5 minus the square root of 41 all over -2. So at that point, if you wanted to change these to all positives, I guess you could. But that's another story. You don't have to do it. And let's move on. The next one, 64 and 12 underneath the radical give me 76. And 76, I think, actually does divide by 4, right? So 4 times 10 is 40. And with 36 left over, 4 goes into 36 9 times. And so this 76 is the same as 4 times 19. Right? So this is -8 plus or minus the square root of 76 all over -6, which changes into -8 plus or minus the square root of 4 times 19 all over -6. And then this turns into -8 plus or minus 2 root 19 all over -6. And then just when you thought the fun had stopped, these are all even, so it can reduce down to -4 plus or minus the square root of 19 all over 3, -3. Yahoo! Wow. All right. And so I totally accept the plus or minus as part of your answer. You don't have to write them as two separate ones. I hope you understand that these are two separate numeric values, even though I'm having you just write it like that. All right. And then the most fun of the three is the 1 plus 24 added together is a perfect square. -1 plus or minus the square root of 25 over 12 can be broken down into two fractions, and the square root is rational number, and I need to keep going with a case like this. You cannot just leave it like that and get full credit. So this is -1 plus or minus 5 over 12. -1 subtract 5 over 12, and then -1 plus 5 over 12. So -1 subtract 5 is -6 over 12, and that gives you -1/2. And then 4 over 12 is going to give you 1 over 3. So fun little nugget of information. Anytime you get a perfect square underneath the radical, it technically means that I could have factored this bad boy. And so the 6x squared plus x minus 1, I see that this is a -1, and I see that's a plus 1, and I know that I can use 3 times 2 to make 6, and so I should have tried to factor it. And so I'm thinking in my head, so this is the 2, sorry, this is the 2, right? 3 times 2 makes the 6, so I want my 3 to be positive, and I want my 2 to be negative when I do this outer inner product. And so I want my 2 to be negative, and I want my 3 to be positive, and so I put it just like that, right? The outer is positive 3x, the inner is negative 2x, and 3 subtract 2 is positive 1. And so if I were to set this equal to 0, you can't just like take the opposites here. 3x minus 1 equals 0 has to be solved. You add 1 to both sides, you get 3x equals 1. And you're asking, why am I doing this? I'm doing this because I can, and because I see people make some mistakes, like they don't know what to do when they have a number in front of x in one of their factors. And so they forget the zero product property because they just take the opposite, you know? So what I'm showing you are two different methods to get to the same ending. And that's because I want you to practice your factoring. And if you do happen to get a perfect square underneath the radical, you could have factored it. And you should have factored it just like me. I should have done it. So the next little topic is in relation to the graph of a quadratic equation. And I showed a little bit of the graph in the first factoring example, that if I have two solutions for x, then that would mean that my parabola crosses twice, and most parabolas do. But not all of them do, and it all depends on what happens underneath the square root. So if you get something like this in the quadratic formula, it means that you have no real solutions. And some of you guys started using the little I, you know, outside if you want. But basically what that means is that this parabola is facing up, and it's shifted so far up that it won't cross the y-axis or the x-axis, or the opposite. It's pointing down, and it's shifted so far down that it will never cross. So if you do get a negative underneath the square root sign, that means there are no real solutions, but that doesn't mean that there's no graph. It just means that the parabola doesn't intersect the x-axis. If you happen to get 0 underneath the square root sign, the square root of 0 is 0. It's just that whatever you have to add or subtract is going to give you the same answer. So negative 2 plus 0 and negative 2 minus 0 are the same thing. And so you only have one x-intercept. And so that looks like x is negative 1/2, and it just dips down, it intersects the x-axis once, and then goes right back up. So the more likely result, more often, I don't know, probably, I don't. What you typically would see in a math book more commonly, I think, is because they want you to have solutions, is whenever you have a positive number underneath the square root sign, that's when you have plus or minus a value, and you're going to get two different things. You know, adding 5 is going to give you one answer, and subtracting 5 is going to give you two answers. And those answers are how many times the quadratic function crosses the x-axis. So you're going to get to a set in the book where they're going to ask you how many solutions there are, and you don't use the entire part of the quadratic formula. You just use what's called the discriminant. So the b squared minus 4ac is called the discriminant. Discriminant. Sorry, I wasn't sure if I was going to go. So this, whether it is negative, 0, or positive, will tell you how many times the quadratic function will intersect the x-axis. So you don't have to do, they're not asking where does it intersect, they're saying how many times does it. Okay, so let's roll through these 3, and then hopefully that's enough information for you to complete the rest of your homework assignment. Please try to complete this for homework. The assignment I'm talking about is the last assignment. It was a different kind of week, but hopefully you still got through these assignments, and we can just try to, keep moving along in the textbook, even though I was out for the week. So here we go. B is 4, b squared is 16, minus 4ac. Multiply these two together, and you get a positive 6. And so this is going to be 16, take away 24. That is going to be less than 0. So you will not cross the x-axis. You'll cross the x-axis 0 times. On this next problem, the A is 1, the B is 1, and the C is negative 6. So this is A, this is B, this is C. So I almost went to the whole quadratic formula again, but right now all I need to figure out is what's going to happen underneath the square root sign. So b squared minus 4 times 1 times negative 6, and that's when it's going to be 1 plus 24. That's 25. That's greater than 0, so intersect 2 times. Excuse me. And then finally, this last one. Again, I am only using the discriminant because that's what makes the difference in the formula when you do the formula for the quadratic equations. Okay, b squared, that's that bad boy, squared, minus 4, 3 and 10 multiplied together, 30, 81, subtract 120, that is definitely less than 0. Did I do that right? I think I did. And so will not intersect. Insect. You get what I'm saying. Intersect the x-axis. Thank you for your patience. If you'd like to try the following three, you can pause the video and try to work with a partner and see what you think. I'll show the answers in just a second, or at least what I got. All right, hopefully you'll let me know if I made any mistakes, but feeling pretty good about my answers. Hopefully you and I got the same answers, and thank you again for paying attention. I hope that you did, and I hope it wasn't impossible to learn math this week. I will see you soon. Have a good weekend. Please do your homework.